Good morning, all. Now, this is the class 4 of your module 3 motion. So, today we learn about momentum. So, the linear momentum, it is represented by small letter m, a small letter p of a particle is defined as a product of mass m and velocity v of the particle. So, p is equal to mv. Now, we know that momentum is a vector quantity, that is, it has got both magnitude and direction. If you have two objects, a heavier object and a lighter object, then the heavier object will have higher momentum when compared to the lighter object. Now next is law of conservation of momentum. It states that whenever two or more particles interact, the total momentum of the system remains constant. That is, P1 plus P2 is equal to a constant, or we can write it otherwise as M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2, where U1 and U2 are the initial velocities and V1 and V2 are the final velocities of masses M1 and M2. So here study the definition of linear momentum, its expression, and then the law of conservation of momentum. It is nothing but whenever two or more particles interact, total momentum of the system remains constant, and just study the expressions also. Okay. Now we learn about a few examples for the conservation of momentum. First one is a recoil of a rifle when a bullet is fired. That is when the gun or the rifle is at rest, then it will have zero momentum. But when a bullet is fired in the forward direction, what happens? The bullet will gain some momentum in the forward direction. But according to conservation of momentum, the total momentum should be zero. So in order to conserve that momentum, or when the bullet moves forward with a higher momentum, the rifle or the gun will move backward in the opposite direction so as to conserve momentum, but with a smaller velocity. Why? Because the mass of rifle is larger than the bullet. Another example is the propulsion of a rocket. So you might have seen this rocket launching. That is upon ignition, the rocket shoots gases downward at a higher velocity. That is, when a rocket is ignited, you can see gases going downward with a high velocity. And since the gases have mass, they acquire very high momentum. So the gas is moving downward with a high velocity and high momentum. But in order to balance this downward momentum, what happens to the rocket? The rocket will move upward at a much lower velocity when compared with the velocity of the gas going down. Why? Because mass of rocket is greater than the gases. So this upward momentum will be the same as downward momentum, and linear momentum is conserved. So this is how it is explained. So study these examples. And another simple example is a penalty kick that you might have seen during a football match. That is, before the kick, the ball is at rest and it will have zero momentum. But when the person kicks the ball with his leg with a high velocity, then his momentum is imparted. Imparted means given. That is, that person's momentum is given to the ball, and the ball will move in the forward direction with a velocity according to law of conservation of momentum. So study these three examples that gives evidence for the law of conservation of momentum. Another important topic is the Newton's law of gravitation. It states that every particle attracts every other particle in the universe with a force F, which is directly proportional to the product of their masses m1 and m2 and inversely proportional to the square of the distance between them. It is R. So study that definition and also the corresponding expression. Here F is a gravitational force acting between the two objects. G is the gravitational constant. m1 and m2 are the masses of the objects, and R is the distance between the center of their masses. So study the definition for Newton's law of gravitation, the expression, and explain what each of these terms stands for. Now this law is very useful to estimate the mass of Earth and other planets by equating it with Newton's second law of motion. Next one is acceleration due to gravity, represented by small letter g. It is nothing but acceleration experienced by a lighter body due to the influence of the pull of gravity of a heavier body. Okay, acceleration experienced by a lighter body due to the influence of gravitational pull of a heavier body. Its value is 9.8066 meter per second square. This means that the speed of a freely falling object increases by 9.8 meters in every second. So study those underlined sentences. Okay. Now we can, the gravity decreases with altitude from the Earth's surface according to the formula. So this is given here. R is the mean radius of Earth, G0 is the value of G at surface of Earth, H is the height above the Earth's surface. Just study the expression and the terms. Now another important topic is rotational motion. Here you can see a circular disc. It is rotating about its axis. When the disc completes one full cycle, the angle covered by the particles at different distances, say R1, R2 and R3 will be the same, that is about 360 degree, 2 pi radians, and angle covered in half cycle will be just the half of 360, that is 180 degree or pi radians. This is just an example to illustrate the concept of rotational motion. Okay, what you have to study is the following definitions. So the first definition is angular displacement. Let us see what it is. If theta 1 is the angle at time t1 and theta 2 is the angle at time t2, then the angular displacement d theta in time dt, that is t2 minus t1, is equal to theta 2 minus theta 1, and that will be the same for all particles at any radial distance. So that is the first definition, angular displacement. So study the definition. Next definition is angular speed. It is represented by the letter omega and is defined as rate of change of angular displacement and is given by omega equal to d theta by dt. That is the second definition. Now the third definition is angular acceleration. It is represented by the letter alpha and it is the rate of change of angular speed. So alpha is equal to d omega by dt. So you have studied three definitions: angular displacement, angular speed and angular acceleration. Unit of angular displacement is radian, whereas that of angular speed is radian per second and that of angular acceleration is radian per second square. So study those definitions, the expressions and the unit of these three terms, which are the angular acceleration, angular speed and angular displacement. Now here the angular speed and angular acceleration, they are they should always taken as positive and their direction is along the axis. Now next is definitions for linear velocity and linear acceleration. Linear velocity is represented by small letter v and is given by r omega. See here it is written v is equal to r omega. R is what? It is the radial distance from the axis of rotation of the object, and omega, that we already know, it is the angular speed. So linear velocity v is the product of angular speed omega and the radial distance from the axis of rotation, that is r. Now another definition is linear acceleration. It is represented by the letter a and its formula is r omega square. So how can you define it? It is a product of the radial distance from the axis of rotation of the object r and the square of angular speed omega. Okay, this is just an example to illustrate the concept of angular speed and angular speed. So just go through that example. But here what is more important for you is to study the definitions, that is angular displacement, angular speed, angular acceleration, linear velocity and linear acceleration, along with their definitions, their expressions and unit. Okay. Now, so in today's class we have studied about certain important topics that are very useful to specify the rotational motion of a rigid body. They are angular displacement theta, angular speed omega and angular acceleration a. So that's all for today. So I will tell you the important topics today. What we have studied is about momentum. Then what study the definition of momentum, its expression, law of conservation of momentum, then various examples to illustrate the law of conservation of momentum. Then another important one is the study this law, Newton's law of gravitation, the expression, and explain each of these terms in that expression. Then finally study the definitions for angular displacement, angular speed, angular acceleration, linear velocity and linear acceleration, their definitions, then their expressions and their units. Okay, so that's it for today. Thank you.